I think now is a really great time to do a postgraduate, partially because a lot of students will need it to get jobs. We're seeing the number of students who do undergraduate degrees rising, and a postgraduate is really what differentiates it.
UL can offer students a huge range of online, blended and part-time programmes designed flexibly so they can fit in work, home and study.
Hello, everybody. My name is Tiziana Margaria. I'm a professor of computer science. I'm the head of department also of computer science and information systems. I'd like to welcome you to this event this afternoon for us here. And to show you, so if you look at my background, it is actually the campus, how it looks like in the night. We have life actually on the campus all the time, including, in the evening, in the weekends, for sports, for culture, not just for studying. But of course, studying is the main course that we have. So I would like to show you, in short, let's say, a video about the campus again. And you're going to get to know today the course directors of nearly all the postgraduate courses that we have. They are both Masters of Science, Master of Arts. We have some courses that are going in depth, some others that are more generalist, some others that are conversion courses. And we have delivery both face-to-face, blended, online, okay, for programs that are between 12 and 24 months. The team is very international. It is rich in terms of diversity of experience. We have educators that are passionate about research, some others that are leading in practice. And so we strive actually in every course to have a good mix of both of them in order to give you the best experience of learning while you're going to be with us. I would like now to show you the video briefly. And then you're going to meet the course directors and see the presentations. I'm going to welcome you again at the end after the Q&A.
Thank you for joining our virtual open day. It is a pleasure for me to talk about this unique program, our new master degree in artificial intelligence and machine learning. I would like you to invite you to watch our pre-recorded video. I will be in the live chat answering your questions.
Artificial intelligence is one of the most exciting areas in computer science and engineering. AI and machine learning address the challenge of creating machines having the capability to learn, adapt, and exhibit intelligence. AI research is changing our lives and leading us to a world with self-driving cars, automated trading on stock markets, AI-assisted surgery, AI-controlled power grids, smartphones that can recognize objects, faces, and speech, search engines that can translate languages, video games that exhibit intelligent behavior. AI is not only exciting, it is a field with tremendous job opportunities. Data scientists and AI and machine learning developers saw a 60% increase in job openings in 2019. Moreover, AI is the driving force of the current industrial revolution, and therefore we expect an increase in demand for these jobs. This program prepares students for industry careers in data analytics, data science, machine learning, and AI. It also aims to give the students the knowledge to potentially become high-profile experts in this field. This object recognition system is based on a deep neural network. But how does it work? What are its limits? You will analyze that in this master's degree. This unique program embraces the new trends in AI by combining established AI techniques like unsupervised and supervised learning, reinforcement learning, deep neural networks, parametric and non-parametric regression classification models, evolutionary computation, Bayesian network and search algorithms, with emerging disciplines and technologies like deep reinforcement learning, causality modeling, bio-inspired robotics, evolutionary and humanoid robotics, machine-supported correctness, probabilistic programming, and explainable AI. This one-year program comprises 10 taught modules plus a project for a total of 90 credits. This program begins with a module titled Introduction to Data Engineering and Machine Learning. You will start analyzing data and train machine learning models. You will learn Python, which is the most commonly used programming language for AI, and the language we will use in all the modules in this master degree. You move on to text analytics and natural language processing, which is an AI technology that uses natural language processing to transform the free text you find in books, documents, and databases into structured data suitable for analysis or to drive machine learning algorithms. As a technology, natural language processing has become of age over the past 10 years, with voice search products that we commonly use in our phones that employ natural language processing to understand and respond to user queries. Given the huge quantity of text that is produced every day, from electronic health records to social media posts, text analytics and NLP have become extremely important to analyzing text-based data efficiently. An important module in this program is machine vision. One of the critical components to implementing all the capability of AI is to give machines the power of vision. To emulate human vision, machines need to acquire, process, analyze, and understand images. The change of pace in achieving this milestone was made thanks to artificial neural networks. Nowadays, machine vision is a critical component of self-driving cars. But how does this system that I'm using for object detection work? It starts with an annotated dataset of images. For instance, for this application, we use a dataset including 70 classes of common objects. Each image needs to be tagged with metadata that indicates the correct class, like cup, cell phone, person, or book. When a neural net runs through the data and after it has found an image with a cup, for instance, it is the feedback that is received regarding if it was correct or not that helps it improve. This is called training in machine learning. The purpose of this module is to provide the students with an overview of the applications of artificial intelligence and machine learning methods to games and game development. You will learn how we can build AI systems that can learn from scratch to play two-person games and reach human level. AI systems that have no prior knowledge beyond the rules of each game. At first, the system makes random moves, then it starts learning through self-play. After a few hours, the system begins performing better than average human players. After a few additional hours, it can beat the best human player. How can we build programs that evolve? The goal of this module is to introduce you to evolutionary computation, that is a family of algorithms inspired by biological evolution. In evolutionary computation, the computer creates a population of potential solutions to a problem. These are initially random solutions, so they are unlikely to solve the problem or even to come close to a solution. But some will be slightly better than others. So, like in natural selection, the computer can discard the worst solutions, retain the better ones, and use them to breed more potential solutions. Part of different solutions will be combined to create a new generation of solutions that can be tested, and, like in evolution, this process can be iterated again and again. Notably, grammatical evolution, that is the most commonly used evolutionary automatic programming system, was invented here at the Department of Computer Science and Information Systems at UL. You will learn this framework, but also you will learn from our experts how evolutionary computation has led to significant advances in humanoid robotics. The second semester will go further in depth. In the module Artificial Intelligence and Machine Learning, you will understand the power but also the limits of the various AI and machine learning techniques. You will learn what is the space of functions that can be learned by machine learning algorithm. You will learn how to implement the main AI and machine learning techniques from scratch. You then move on to deep reinforcement learning. It is indeed the combination of deep learning with reinforcement learning that has led to AlphaGo beating a world champion in the strategy game Go. It has led to self-driving car, and it has led to machines that can play video games at superhuman level. Reinforcement learning refers to goal-oriented algorithms, which learn how to attain a complex goal by maximizing some reward function. For example, they can maximize the point won in a video game, or they can optimize the trajectory of a robotic arm to complete a certain task. In this module, you will learn theory and application of this new emerging artificial intelligence area. This is the first master in the world that has a module about probabilistic and explainable AI. Standard AI machine learning systems cannot say "I don't know" or "I'm not sure." Dealing with uncertainty is one of the greatest challenges in decision making. For instance, autonomous systems don't have good ways to respond to uncertainty of the real world, and they don't have a good way to understand how the uncertainty of their sensors affect the decisions they need to make. Probabilistic AI is a strategic research area that will take artificial intelligence to the next level. This new master degree will allow you to learn how to design AI algorithms that can deal with uncertainty. Another problem with standard AI systems is that the solutions they generate are often hard to explain. For example, even if an AI system may create a solution with a perfect outcome, how it actually works may be a mystery to a human programmer, as the system may have produced complex functions that are difficult to interpret and understand. Explainable AI deals with designing explainable systems, which lets humans understand and articulate how an AI decides to suggest a certain medical treatment or to reject an application for a mortgage loan, or, as in this toy example, how AI learns painting a seal escape. In order to deploy AI systems in existing enterprises, you need to be able to engineer artificial intelligence. The aim of this unique module is to prepare students to understand and use new technologies focusing on the sharing, composition, reuse, and retrieval of AI algorithms and data, as well as on guaranteeing system-level correctness, compliance, and quality. This program is completed with a module on research methods and project specification, where you will gain the research skills to carry out your final research project on AI and machine learning. In this exciting final project, you will apply the knowledge learned in this degree to solve complex problems in health systems, smart manufacturing, business analytics, quantitative finance, video games, and many others.
Okay, thank you for your attention. If there are any questions, I will be happy to answer in the online chat. So okay, there is already one question. Okay, so there is a question that is more personal about application on different master in RTL. I will answer this offline. It's not any a question of general interest, but I will answer offline. So, are there any questions about the program, about learning outcomes, or anything else what you want to know about this program? So I just want to know that we know that we are all faced with an unpredictable amount of uncertainty at the moment due to the virus, but AI and machine learning, it's really our future. So we are sure that there will be jobs offer as soon as everything opens again. And so I think it's very important to be prepared for a career in AI and machine learning. So this is why I would like to invite you to join our world unique master degree in AI and machine learning. So please, if you have any other questions that you want to talk about, we'll be happy to answer. Okay, if there are no other questions, then I can now pass the microphone to Dr. Cristiano Storni, who is the course director of another awesome program at Thesis, the master degree in interaction and experience design. So I would like to thank you all very much for coming. Please feel free to contact me at any time via mail. And if you want to know more detail about this master, you can find all the information online on the webpage of this course. Thank you for your attention, and please, Cristiano, go ahead.
Hello, everyone. My name is Cristiano Storni, and the course director of the Master Program in Interaction and Experience Design, offered by the Computer Science and Information System Department at the University of Limerick. So the Master Program in Interaction and Experience Design is a 12 months intensive conversion course. It runs from September to September. It's very intense. We keep you busy with a lot of lectures and a lot of assignments, group assignment and individual assignment. And it is a conversion course, which means it doesn't assume any prior knowledge in any of the subject area, but we will start teaching from scratch and we will move fast, which reaffirm how intense the teaching and the learning will be over the 12 months. The master program is characterized by two main components: a technical component dealing with digital technology and new emerging computing paradigms, and the design component dealing with methods of how to design things, regardless of what you design. So on the technical domain, our unique selling offers is our broad notion of interaction. For us, interaction is not just screen-based interaction. And so while we acknowledge the importance of mobile computing and web computing, which we deal with, and it's very important, we also acknowledge new emerging computing paradigms. Think of augmented reality or the Internet of Things, physical computing. They actually go well beyond the screen-based interaction. They go back to physical interaction in the real world, thanks to new emerging computing paradigms. And so for us, interaction is not just screen, but is using sensors and actuators, prototyping platform to actually build physical stuff. And in this sense, our discipline, interaction design, it overlaps with architectures, with product design, and not only with traditional interface design. On the design side, our unique selling point is our competencies, almost unique competencies in Ireland in human-computer interaction and user-centered design. So you're going to be taught how to organize design processes that are centered around the stakeholders who are going to be involved by your design intervention, or the users who are going to be using what you are designing. And in this sense, we teach you a lot of approaches, methods, techniques, tools in user-centered, human-centered, participatory design. The course outline: the course is divided into 3 semesters. It's 12 months, so 4 months each. The first 2 semesters are taught semesters, so you should be expected to be given lectures. Lectures are called modules, and modules have subject to deal with. In the first semester, you have 2 core modules that are mandatory for you, and then you actually pick 2 out of a pool of 5 elective options, which gives you a little bit of flexibility and the ability to personalize your learning experience a little bit. That's the same structure in the second assignment, where you have sort of building on what you have learned in the core module in the first semester. And so you still have 2 core modules in the second semester, and then you have the possibility to select 2 electives out of 4. And the third semester is not a taught semester, but you are expected to work on a final project. So you're going to be assigned a supervisor who have competencies in the area that you have selected for your final project, and you will develop a final project which you will be examined at the end, and which you will exhibit at the end, because we have this exhibition of final project. What you're going to be learning over the 12 months? Well, in general, the 2 components. So you have, on the design side, you will be able to apply an interaction experience design theory, approaches, techniques, tools in practice. As I said, you will develop a final project, so that will give you a hands-on, first-hand experience of developing an interactive multimedia project. It is not just about designing screens, but it might be time management, resource management, building physical stuff, and so on and so forth. You will be able to be fluent and familiarized with a lot of software packages, so what the industry wants on the one end, so Adobe stuff, but also some open source software. You will be able to modify, read, write basic code, even if coding is not, and it will not be your cup of tea. The master program, it gives you exposure to it, so you will be able to actually understand what's going on, which might eventually put you in a better position when you have to actually talk to developers and better understand what they do and make your design better fit what are the technical requirements, and employ human-centered and participatory design methods, which I said at the beginning. What you're going to do at the end, well, it depends on you. The interaction design field is quite broad. It is, in fact, a new profession, a new job. So there's a lot of agency looking for IX, UX people who develop interfaces, test them with people, who actually try to engage with people, trying to understand what they want and what they need, and so on and so forth. But there are a lot of different destinations. I mean, game is becoming big. Gamification is even bigger, which try to apply game logics into different areas of life. So we talk about game for rehabilitation or for learning and so on and so forth. Social media and digital marketing is also becoming quite big, and someone who is familiar with the interface is well positioned to perform well there. Some of our students end up in research and education because they actually enjoy the research and they want to do a PhD. Some other end up either working for big corporations like Accenture, Apple, Amazon, Disney, Google, IBM, SAP, Microsoft, or to develop their own small startup because they have projects and they want to develop those. As I said, at the end of the third semester, you actually present a project that you have developed over the summer. Now we have a page with all the projects that you can browse to get a sense of how broad and how different the projects are, how many of them goes well beyond the screen-based interaction, how most of them are human-centered in their development. In this case, if you actually visit this URL, you will get to a page with a lot of testimonials and previous students who talks about their project with us. I just want to share maybe a testimonial. This is the URL I was talking about. This is ixuxdesign.csis.ul.ie. If you go under testimonials, you see a lot of video of students who actually share what they have learned with us. Let me just play one to give you a sense.
Hi, my name is Martin Crowley, and I'm a recent graduate of the Masters in Interactive Media in UL. To talk about, first of all, my background before entering the course, I basically did an undergraduate before it in music production, but it was kind of unorthodox because during that undergraduate I was doing a lot of coding, so I was coding kind of VST synths and virtual synthesizers and something like and things like that. So the reason why I chose the master's then directly after that was because when I was making these synths, it was kind of for like either for assignments or for myself basically, and I didn't really have a very good grasp of the end user and like the needs and wants of the person who will actually be using the synth in the end. So basically it made sense for me to pick the interactive media masters because that is one of the fundamental learning aims of the course is to teach you the human element in designing interactive systems. So having completed the year at this point, looking back, I thoroughly enjoyed it. I got loads out of it. Initially, I was quite apprehensive about like not having the certain skills like design skills, having no background in that, or being immersed in audio for so long. Like even sketching was kind of a new realm to me, but that didn't really seem to matter in the end at all because all the modules basically began at a very basic level and built from there. Also, the class were from really varied backgrounds, so I also found that I learned loads from my classmates, particularly during group projects. My favorite thing about the course basically was the unexpected hands-on nature of the course. There was quite a bit of digital fabrication, 3D printing, laser cutting, and I just really loved getting my hands dirty with, you know, electronics, like things like that. So it wasn't just like coding or like design. There was quite a bit of actual hands-on building of stuff, and I just really loved that element. For my final project, I basically fully embraced that, and I used all the excellent facilities that were there, and I just built something that was just really hands-on. It was actually just a physical interface. The idea was to get away from screens, but a physical interface for a music program that I use quite a bit, and I really enjoyed that. I would say for your final project, just really pick a subject that you love. I was very lucky that I was fully vested in it from the beginning, and to me it didn't feel like work at all, because it was just a joy basically to go through the whole process, because I knew I was doing something that I loved. So my goal now, basically, I deliberately geared my final project kind of to have something in my CV, because my goal now is to design interfaces for digital musical instruments and MIDI controllers and hardware synthesizers. And I think from basically everything that I've learned in the last year, I'll be in a really good position to get a decent job somewhere along that line. So, yeah.
And so this was the story of a student with a strong technical background who needed design, and that's what he got. His final project was to move beyond the screen-based interaction and actually use the software he was previously used to use, but by operating physical object now, which reaffirm one of our selling points. But it could be easily a story of someone with a strong design background and not technical strength who wants to actually learn more about digital technology. And so, as I said, we have a lot of testimonials of different experiences, and they're all quite positive. How to apply? There's a big link in the webpage that I just shared. There's another link here. We don't have very, very tough requirements, so just a primary degree in any subject area with a first or second class honor. You also are required to submit a portfolio of creative works, which I will use to actually conduct the interview with you. And that will be it. Here you have my name, Cristiano Storni again. You have my contact detail. Don't hesitate to send me an email if you need. And don't hesitate to visit our website, which we made to actually share all the material that we can with you. So there is a student-centered FAQ with a lot of interesting information, and I hope it helps. Thank you very much. Thanks for your attention. Hello there. Hi, everyone. If you have any question, I'll be happy to answer. I think I did on a couple of occasions by writing on your Q&A chat. I was never really sure whether you were asking about my program or not. If you anonymously ask about a program, maybe you might want to specify what program you are asking your question about. I don't see any other questions, so maybe I can pass on to my colleague, Carrie Hagan, for the presentation of the Master Program in Arts and Technology.
Welcome to the presentation on the MA-MSc in Art and Technology. I'm Dr. Carrie Hagan, and I'm the course director. I also teach real-time audio and video in the first semester, and the studio module in the second semester that focuses on personal practice. I'm a composer and a researcher in the field of computer music, with specializations in real-time methods for algorithmic music and spatial audio. Today's presentation will briefly introduce the faculty of the Digital Media and Arts Research Center, or DMARC, who teach on this course, and I will also describe the state-of-the-art facilities for the course. Then I will explain the modules and what you can expect from them. Jürgen Simpson is the director of DMARC, and he teaches time-based media in the first semester, and co-teaches the Collaborative Art Studio, Studio 1, in the second semester. In addition to his arts practice, he is a founding researcher and practitioner in the discipline of screen dance. Giuseppe Torre teaches code and art in the first semester and research methods for art and design in the second semester. Dr. Torre's practice reflects philosophical and aesthetic questions on the art and nature of code itself in the service of creative practice. Dr. Neil O'Connor is a performer, composer, and producer who has specialties in electronic music and film. He teaches our fundamentals of audio, video, and programming in the first semester. Dr. Nicholas Ward is a researcher and artist in interactivity and physicality. He teaches the module on physical computing in the first semester and co-teaches the collaborative Studio 1 in the second semester. Dr. Robin Palmer is an artist and researcher with a focus on philosophy, installations, and live performance. And now for an introduction to our facilities. We have a studio suite that contains a state-of-the-art live room, acoustically treated and isolated from the building, with built-in patches to the production room. We also have a 5.1 production studio and a separate composition studio where we have analog and digital synths. This image shows the 5.1 production studio. Our teaching space is also our postgraduate lab. Designed for collaborative work, it also functions as a small makerspace. Our students also have access to makerspaces in the engineering building and the Fab Lab in the city center for more advanced uses. We also have an electronics workshop for use with our physical computing module. This includes circuit elements, soldering irons, breadboards, sensors, wires, everything else required for physical computing. We also run the Spatialization and Auditory Display Environment, or SPADE, located in the basement of Glucksman Library. This is a 32.2 channel high-density loudspeaker array that researchers use for composition, spatial audio research, psychoacoustics, and audio engineering. Our course runs over 12 continuous months, split into 3 semesters of 30 credits each. In the first semester, our modules are focused on bringing everyone up to a similar level of expertise in the fundamental disciplines of art and technology. Modules are practice-based, mostly assessed through projects. In the second semester, a research methods module prepares you for your thesis research, while studio modules focus on developing your arts practice, both individually and collaboratively. There is also an opportunity to take an elective to hone your studies for your particular practice. The summer is a self-directed thesis and project supervised by a mentor from the DMARC faculty. Fundamentals of Audio, Video, and Programming is taught as a boot camp to bring everybody up to speed on the basic hardware and software of media production. This module introduces you to the use of our studios and equipment, as well as prepares you for your programming modules in the rest of the year. Time-based media is an arts and practice-based module that includes electronic composition, filmmaking, sound art, and any other screen or sound-based art in a fixed medium. In contrast, real-time audio and video looks at screen or sound-based practices in real-time media, focusing on algorithmic or generative practices. Code and Art is an introduction and development of skills in popular visual coding languages, which also critically reflects on coding itself. Physical computing teaches the use of sensors and Arduino-based devices for the purpose of wearables and art or sound instruments for performance. In the second semester, Research Methods for Art and Design teaches the unique way artist-researchers must approach their practice in the academic context. This module prepares you for the research element of your final thesis. Studio 1 is a project-based module where your cohort is broken into groups who design and build an artwork in response to a brief that's typical of professional organizations' calls for works. Studio 2 is a project-based model designed to develop and expand your portfolio while focusing your practice into your thesis project. In the second semester, you can choose an elective from Aesthetics, offered by Mary Immaculate College, Digital Fabrication, offered by the School of Architecture for use of their Fab Lab, Utopian Theory and Texts, from the Arts, Humanities, and Social Sciences faculty, or 2 more programming languages in Thesis. For those especially focused on an MSc over an MA, Event-Driven Programming is an advanced coding module. For the final thesis, you'll submit a deliverable supported by a thesis. The research question or proposal determines whether you are submitting for an MA or MSc. You get to choose. At the end of the summer, projects are showcased with the MA, MSc in Interaction and User Experience Design. As an MA, MSc, you can proceed into a personal arts practice using audiovisual technologies. You can pursue more technical careers in programming, production, or engineering. Or you can continue practice-led research, either independently or in continued postgraduate studies. We require the basic English standards that UL requires for non-native speakers. We are looking for a 2.1 or higher undergraduate degree, or more importantly, equivalent work or practice experience. We also require a portfolio of your work in audio or visual media. This is especially important for those applying with equivalent work practice experience rather than a degree. If you have any questions, feel free to email me at kerry.hagen@ul.ie or explore our website at www.artandtechnology.ul.ie. Thank you. If you have any questions, I'm happy to take them. Some of the things that may not have come across is that the Masters in Art and Technology is a conversion course, much like the course in Interaction and User Experience Design. The Art and Technology course is designed to bring people into a multidisciplinary practice. So if you're a computer scientist who does art on the side, this might be a course that can help you develop your artistic practice. If you're an artist who wants to incorporate technology, digital technologies, then this course will allow you to do that as well. It will bring you to that. You can elect to take either an MA or an MSc, depending on what your final thesis project is. So you can pretty much tailor the course to the kinds of sort of career you want to pursue. But I'm not seeing any questions, so I might just say please feel free to contact me offline or to ask questions in the Q&A, and I will then hand this over to my colleague Michael English.
This presentation gives an overview of the MSc in Software Engineering. My name is Michael English and I'm Course Director for this programme. So why choose this programme? The MSc in Software Engineering is a one-year taught programme with a broad curriculum and pathways in software and data analytics. The CSIS department has strong connections with industry, which we leverage in delivering this programme by inviting industry guests to lecture on the programme. We have world-renowned academics in software engineering based in our department, who are also part of LERO, the Software Research Centre, which is based on the UL campus next door to the CSIS department. The employment rate from this programme is very high, based on a thriving ICT sector in the Limerick region and across Ireland, and the reputation of UL in preparing graduates for employment. The minimum entry requirement for this programme is a first or second class honours degree or approved equivalent professional qualification in computer science or a cognate discipline. A degree in a cognate discipline should have a significant software component, including, for example, programming and data structures. It is important to have programming experience either through your undergraduate study or your work experience, or both. Work experience in the software domain would be an advantage, but it is not a requirement. If you have developed or worked on the development of a reasonably large software system, either in undergraduate study or industry, then you understand at least some of the complexities of designing, developing and maintaining software. This master's programme introduces the state-of-the-art approaches to dealing with the complexities associated with software, including its design, development and maintenance. The programme is composed of 2/3 taught courses and 1/3 is a development or research project with a dissertation. Continuous assessment takes place throughout the academic year, and students will work individually and in groups on a range of projects, including requirements documentation, design documents, implementing design patterns and software development. Other projects will involve writing research papers and other reports and presentations. There may also be some end-of-term exams. In this detailed view of the programme structure, you will see that there are core modules each semester. In addition, the programme has 2 streams or pathways. Stream 1, Software Process and Maintenance, and Stream 2, Data Analytics. Each stream has 3 modules, 1 in Semester 1 and 2 in Semester 2. Each student chooses one stream and takes all 3 modules in that stream. Having completed the first 2 semesters, a student can continue with the project in Semester 3 or has the option to exit after Semester 2 with a graduate diploma in software engineering. As you can see, the curriculum covers a wide breadth of subjects. For example, in Semester 1, in Research Methods, you learn the steps involved in writing a research paper, which culminates in the production of such a paper. Concurrency is taught through the Go programming language developed by Google. In machine learning and applications, the final project is a machine learning competition where student teams compete to find the best machine learning algorithm to predict if a piece of software has defects. Data mining involves a series of Python exercises that introduce the main steps of the data analysis workflow and a project which applies these steps. And software design involves a project that implements a set of software design patterns. Thus you can see that this is an applied programme that combines theory, research and practice. It introduces technologies such as the Go programming language and Hadoop, and it involves coding projects and exercises in Go, Python, and in either Java, C++ or C#. Many lecturers on this programme are members of LERO. LERO at UL is part of the CSIS department. It works with approximately 50 companies at any one time, and its 15 years of world-class research collaborations with industry has culminated in receiving international recognition in the form of the 2018 IEEE Distinguished Synergy Award, which places it in the esteemed company of previous winners such as Microsoft Research USA, Carnegie Mellon Software Engineering Institute, and the Fraunhofer Institute of Experimental Software Engineering. One recent example of LERO's collaborations with industry is with Huawei and is worth €6 million. This programme prides itself in ensuring that students graduate having attained UL's graduate attributes. They are more knowledgeable due to the combination of research, theory and practice that they have been exposed to. They learn to be more proactive because continuous assessment and project and group work require students to be enterprising and motivated and to take charge of their learning. Graduates are creative because they develop innovative software solutions for real-world problems and they develop prototype user interfaces and conduct research. They are responsible because they manage and lead project teams and deliver project solutions to assessment deadlines. They are collaborative because they work with their peers and teams on many projects, and they are articulate because they write documentation, reports and papers and give presentations throughout the course of their study. There is a wide range of employment opportunities available to graduates across many sectors. The majority of graduates work in ICT in the software domain, and others may work in ICT within, for example, the financial, health and medical device sectors. Graduates are employed both nationally and internationally. In Ireland, approximately 65% of graduates are employed in either the Midwest, that's the Limerick region, or in the Southwest, but also a substantial portion are employed in the East, mostly in the Dublin region. As you are probably aware, the ICT sector in Ireland continues to thrive, and there is currently a shortfall in ICT skills, especially in the software domain. There are many ICT companies based in the Limerick region. These include Action Point, ACI Analog Devices, Dell, General Motors, Verizon Globex, Jaguar Land Rover, Johnson & Johnson, QAD and Redfair International. These companies have regular recruitment drives on the UL campus, and some speak directly to the students on the MSc in software engineering when they visit the campus. Previous graduates also work with multinationals in Ireland such as Amazon, Ericsson, Fidelity Investments, Intel and Microsoft. Starting salaries range from 25 to 30k per annum, right up to 55 or 60,000 euro per annum. So I hope that gives you an insight into the MSc in software engineering at UL. If you have any questions, please feel free to ask. I can be contacted by email at michael.english@ul.ie. Thank you.
Okay, thank you all there very much for listening to the presentation. I've answered one or two questions there in the chat. If you have any other questions, I'm happy to take them. Okay, maybe if there are no other questions, you can continue to add them to the chat if you wish, or you can email me at michael.english@ul.ie. Otherwise, I'll pass over to Tabea, who is going to present on the MSc in Software Development International Systems.
Hello and welcome to the presentation on the MSc Software Development International Systems. My name is Tabea Deville and I am the course director for this program. This is a 2-year program which takes place face-to-face in Limerick, in Ireland of course, and it's a full-time program with 120 credits, and we start in the autumn semester. This is a program that is aimed at those who want to learn about software development and who do not have a previous computing degree. I will talk about the target audience a bit more in a moment. The other focus of this program is on international systems, which I will also talk a little bit about more. And that means we teach there software localization, internationalization, and language technology. The overarching goal of this program is to prepare students for interdisciplinary fields. This means that while it is suitable as a conversion degree where you could switch away from your current field into software development, our actual goal is to prepare you so you can use your current field in combination with software development and the understanding of software development topics. As such, we therefore have the two underlying or the sub-goals, which are to help you come out of this program with an ability to develop software systems which are customized for individual locales. So that means international software systems, systems that can be used for international markets, and also the capability of researching new trends and approaches in software development and software internationalization. This is incredibly important in this field because it is very fast moving, and at a university program, our goal is not just training where you can perform certain activities, but also to be able to stay up to date with a field. In this program, you learn software development from scratch, which means that you do not need previous software development experience. However, it can be beneficial if you have done some development, some programming before. what we have found is that some of our students come to us and they have no experience at all, which is fine. But then some of them also come with having programmed previously or having done other computing degrees without heavy software development background, which is also a positive experience for them because they are generally able to advance into more advanced topics on the side. So that don't worry if you have done some programming before. Usually the program catches up with you quite quickly. You need a first or second class level 8 honours degree in a complementary program. For example, linguistics, arts, humanities, social sciences, science, business, health or medicine. If you have a previous software development degree, then this is not the right program for you. However, if you are uncertain, please feel free to contact me and we can discuss whether this is the suitable program for you or whether a different one of our programs might be better. You also need to be able to demonstrate that your English language knowledge is of a sufficient standard. This program prepares you for a range of potential fields and jobs, like a junior software developer. You could go into requirements engineering, database development, software testing, but there is also the areas like localization engineer, translation technology consultant, internationalization consultant, which means that you would specialize in the international markets and how to get the technology ready for these particular areas. However, there is also the possibility and the great opportunity by combining what you previously have done with software development to specialize in an overlap between your current field and what you will learn in this program. For example, if you have a law degree, it might be quite interesting to specialize in law and technology, or if you have a degree in project management, then maybe a technical product owner or project management position might be attractive for you. So there are many different possibilities of what you might do with this degree afterwards. The contents are spread out across 4 semesters in the 2 years. So you do a little bit of programming in every semester, you do a little bit of research, you do a little bit of the other topics in each semester. So basically we can think of, first of all, the programming content area where you learn Java. In programming 1 and 2, you learn web database and mobile application, and then software design is about making good object-oriented software. Then the second content area would be software engineering development paradigms, which means different ways of approaching software development, for example, agile methodologies. Requirements is about understanding what is needed for development, human-computer interaction. You learn about making software that is easy to use, that serves the user well, that can be used intuitively and for different audiences, and then of course software quality. The third block would be the international specific areas. So there we have language engineering and translation technology. There you learn some natural language processing with Python, and you learn about the translation technology that is used to internationalize or localize rather the software that you develop otherwise. There is best practice software internationalization, which helps you understand how to design and develop software so it is suitable for international markets, and translation technology systems is about interoperability, process automation, and standards. And then in the fourth block, there is research methods and quantitative research methods, where you learn how to conduct research and also read academic literature. And then there is a dissertation which is spread out over the last year in the first and the second semester. If you would like to know more about this program, you are welcome to contact me at tabea.deville@ul.ie. You can also consult the website and the documentation that I've linked there. Further, there is some social media you might want to follow. Over the coming weeks, there will be some content made available that will give you more in-depth insight into the program, but also discuss career development ideas and continuing education ideas in the field in general. Thank you for your time, and I am looking forward to hearing from you soon or meeting you in Limerick, maybe in the autumn. Okay, so I'll be taking questions now. Okay, I can see there's one question. They've not previously linked into this actually in this course. I don't have an answer for you, Jack, I'm afraid. So the question is whether software development graduates in the HDIP have previously linked into this and if they would link into year 1 or 2. But if you want to send me an email, I'm going to find out and answer that question there for you that way. Any other questions for me? Okay, it seems like there's no more questions. So next up will be Conor Ryan.
Hi there, my name is Conor Ryan and I'm going to talk to you today about health informatics at University of Limerick. So what is health informatics? It's the science behind the convergence of healthcare, information technology and business, and it manages all aspects of effective planning, collection, organisation and analysis of the use of data to create information. And this is very important in healthcare because we have lots of data, but it's really only when it has become information that we can use it. We then connect healthcare with this information to promote wellness, provide better healthcare, and to protect patient safety. This is Ireland's longest running Masters in Health Informatics, and our course has been running for 10 years. Typically, up to 50% of our lecturers are current practitioners, so these are people who are working in health informatics, who have real hands-on experience of the material they're going to be delivering. We generally have small class sizes, so typically less than 25 people per class, and our material is delivered in a blended way, meaning that about 50% of the material is delivered online, the other 50% in face-to-face. We do this by having 5 blocks of lectures. These blocks take place on a Friday and a Saturday, and they facilitate students to stay working full-time while they're doing this course. Many of our students work in healthcare, so we have healthcare professionals, but we also have administrators and clerical officers, as well as general managers. We also have people who are IT specialists. Typically these people have a primary undergraduate degree in healthcare, but we also welcome applicants with relevant work experience. This is a 12-month course. We look at existing technologies and applications and how to conduct research into health informatics. And we also look at new technologies and project planning. Over the summer, students write a dissertation, often related to some health informatics issue or to a study in their workplace. And at the end of this presentation, I'll give a link to full descriptions of each of these modules. Students get to choose their own dissertation topics, and these can be anything from using information computing technology to improve particular treatments, to the impact of ICT systems on hospitals in general, on various healthcare processes, on data analysis, and more recently we've had students looking at AI in healthcare and topics like computer-aided diagnosis. So that's a brief introduction to health informatics at the University of Limerick. I'll be around for a little while to answer any questions you might have, or you can drop me an email there. My name is conor.ryan@ul.ie, and I've also put a link to full descriptions of each of those modules that we talked about on the earlier slide. So thank you very much. Hi folks. Okay, so we have a question and it's about somebody who has a background in computer science. Now, it basically depends on what work experience you have. So typically what we have are people who have about 5 years work experience in the field. So if you're not sure, just send me an email and we can have a quick conversation and we can talk through your options. Okay, do you have any other questions? Okay, folks, well, look, if there are any other questions, just please send me an email. My address is connor.ryan@ul.ie, and we can have a conversation. So I'll pass you on to Professor Tiziana Magria, who's our head of the department.
Okay, you've seen the quick presentations of all the courses. You've seen actually also some glimpses of the labs and the facilities that we have in the department. We are keeping them, of course, as modern as possible, and we have, additionally to the educators, to the teachers, we also have technical staff that is knowledgeable in the use of all the equipment and the new technologies. Okay. You also heard that we have a good collaboration with practitioners, both, of course, in the area of healthcare informatics, but also in the other classes, in the other courses. So you're going actually to have a combination of practice-driven education in all of these courses, and also the theoretical foundations and the research aspect. Okay, so the idea is actually to prepare all our students, ideally, in the best way, both to become professionals in the areas that they chose, or also to continue with research. Okay, so after the master's, there is the possibility of taking up a job, or otherwise we have possibilities for PhDs, for instance, in the CRT in AI, which is basically a big graduate school, national graduate school, of which I am the UL director, specifically in AI. Okay. So both from the master in AI, master in software engineering, and several other backgrounds, they are suitable for that. But also there are many positions in research in some of the centers that you have already mentioned, like for instance, Michael English mentioned LIRO, which is the National Research Center on Software, which is headquartered in Limerick. I am a PI, principal investigator in that course, for instance, in that center, for instance, Connor Ryan as well. There is another one, Confirm, which is about smart advanced manufacturing. So if you are working on the production side, so to say, on the masters in user experience and in arts and technology, you may have maybe an interest in that, in building, in digital fabrication, and you could have a future in there. But also in the health area, we have the Health Research Institute in UL that is ramping up research. We have just other initiatives that are connected with research in the context of COVID. A number of the presenters have contributed to some proposals in this area. Okay, and so also for your own dissertation, for instance, for the project that you're choosing, you have, of course, the option of choosing something on your own with companies, or in research, or maybe both, research connected with companies. Okay, so some people may be worried about what happens in September. We are preparing ourselves to teach the first semester and also the second semester in part, okay, in a combination of online and face-to-face. Some of the programs were already conceived like this. For instance, the Master in Healthcare Informatics typically has, let's say, a presence on a number of weekends on campus, and then there is a blended part, okay? Others were more traditionally conceived as being face-to-face, but, relax. We actually have a team that is very, very knowledgeable in online teaching. Just to give you an example, I mean, the faculty and the university, they have awards for top teaching performance. Thesis representatives have actually won both the last year's award and this year's award. Last year it was Connor Ryan that you've just heard talking about healthcare informatics with his team, and this year it was the full online master in AI, which is a different program to which we also contribute 50% of the modules, which was basically with the team of Dr. Nick Nikolov, who is a database and data analytics expert in Thesis. So a number of the modules that have been listed today, they will be taught by him, right? So together with this, we also have facilities and systems, as to say, for professional education online. And so in either case, you're going to be in good hands, okay, in the autumn, okay. Just looking whether there are fresh questions in general, okay. Well, not for me. We hope actually that to have woken up your interest or confirmed your interest in our offerings. Maybe just one more thing, a number of offerings are unique in the country, like, for instance, the new Master in AI and Machine Learning, as Alessio already said in his presentation. Many of the modules that are there, they are unique in the country and actually beyond, because we know what happens elsewhere, and we know that this is a unique offering. Why? Because the people that are teaching there, they are actually renowned worldwide experts in AI in specific areas, like the probabilistic computing, like the evolutionary algorithms, like software integration, so to say, for AI ecosystems. Well, that's mine, Conor Ryan, and Alessio Benavoli that I just mentioned, so to say. So we know that we are giving something that is not available elsewhere. Okay. The same is for the Master in Software Development for International Systems. That's actually a master in which many universities want to have collaborations with us for the specific knowledge and competence that we offer. Companies are interested or have been interested in recently, so to say, to get training for companies in this area. So we know also that there are jobs. And in this context, we also know that this is, special. And also for the Master in Healthcare Informatics, as Conor said, it is unique in the country, and it has an excellent track record. The Master in Software Engineering is probably one of the oldest ones. It is one of the ones that, that we're proud of ourselves of having basically 100% placement basically before the students finish. The others are also very, very well received by industry and by employers. In that one, you have seen that there are 2 tracks. So we are actually trying to combine, let's say, all the possibilities in order to, in answer to feedback, so to say, by the students, in order to give the best experience to every student that comes to us. I look forward at this point to, welcoming you all in person, if possible, otherwise virtually, coming September, when we are going to go to really start the classes. And if you have any questions, well, please refer probably ideally to the course directors who have given you links and maybe some indications in the chat. I'm also going to give you my email. I'm of course available for any kind of question that you have. And okay, we look forward to meeting you here in Limerick, and to spend the next 1 to 2 years together, creating the future of Ireland and the professions. Thank you.